Hi. In today's video, we're going to be discussing fault-tolerant API strategies. And the topic that I want to talk about with you today is going to be around timeouts. Essentially, the whole point around timeouts is that this is going to allow us to time out an API before an SLA is breached because of a downstream system. So what I want to discuss first are what risks are we going to avoid? So the first one that we want to talk about is the fact that a timeout strategy is going to allow you to avoid a breached SLA because of a downstream system. So what I mean by that is, say we have a downstream system that is going to take too long to respond back to you and therefore cause your API to breach an SLA that's set by a customer. You want to be proactive with that and return a failed response before the SLA is actually breached. So what we're going to do is we're going to avoid a breached SLA because of a downstream system. The second risk that we're going to avoid is the fact that your downstream system is taking so much longer. It gives you a higher probability of a chance that there's actually bad data that's going to be coming from that system. So there's a higher than normal probability that you're actually going to have bad data come through and it's going to end up failing anyways. So by putting in this timeout and avoiding spending too much time because your downstream system is taking too long, you're going to avoid the probability that you're going to have bad data anyways. So we're going to avoid the probability of higher than normal probability of failure. Okay, so let's start by actually looking at what this pattern looks like in practice. So if we start with our client that's going to actually be calling the API. So the client will it'll call an API, which will in turn call a data source. Or this could be some other system. It doesn't necessarily need to be a data source. It could be another API, something like that. But the whole point is it's going to be downstream. So the first thing, if we were to look at this client is going to call the API. And at this point, this is where we're actually going to start our clock. Few things I want to discuss about this. So this is actually going to be the amount of time that we're actually going to wait before we send back a failure message. And what we want to discuss with that are some key considerations for what this number is and how much time that is. So the first consideration we want to think about is that it needs to be in line with your SLA. So if your client has an SLA that says you need to have a response back in X number of seconds, you need to make sure that your timeout is going to be less than what that SLA is. The next piece is that you want to make sure that this timeout period is as small as possible. That's going to give you the best chance of avoiding that breached SLA because of the data sources. Generally, where you're going to figure out what that number is going to be around performance testing. So you're going to do performance testing, understand what the average response time is supposed to be, and then you're going to want to set your timeout period right in line with that. So we want to, number two, make this as small as possible. And so now let's take a look. We're going to go back to this. Our client's called our API. We've started our timeout clock. The API is going to go and send the data, the information down to the data source. But we're going to have a delay here. This delay is going to cause us to breach this timeout. So we've gone past the amount of time that we're expecting this data to come back. So this API, whether or not this is actually sent back the response, is going to send back a failed response over here. We're going to say, okay, I don't care how or that you're taking too long. I'm sending a response back to the client that says we're not getting data back in time. We're getting a failure. That client then could have some kind of a process that says, okay, if I get a failure, I'm going to actually go and retry this. Or you could have a circuit breaker, any of those other types of patterns that can go and be used to avoid any kind of fault tolerance. So now the client, say we do have a retry process, we're going to go back, we're going to recall this API. This API is going to call the data source, and this time we are getting the response back in time, and therefore we can go and send the client back the data that they initially requested within the amount of time that they're expecting it. So to quickly recap, we have the timeout pattern that's going to help us avoid breaching SLA. It's going to avoid the higher than normal chance that we're going to have bad data coming back. We're going to ensure that we're keeping that timeout in line with our SLAs and that we're keeping it as small as possible. And so with that, this is the timeout pattern for fault tolerance, and have a great day.